Good evening, everyone. Okay. Today we are going to discuss about continuation of our last class, that is semiconductor devices and memories. Okay. So in our last class we are discussed about memories. Na? So in today's class we are going to discuss about diagram, comparison between the static and dynamic RAM, and comparison between the RAM and ROM, and also what is the need of flash ROM. So these are the topics today we are going to discuss. So before going to discuss about today's topics, once I would like to revise last class topics. Okay. So in our last class we are discussed about what memories. Okay. First of all, what is meant by memory? Okay. First of all, what is meant by memory? So while coming to the word memory, it is used to store the binary information. It is a device which is used to store the binary information, whether it may be in the form of electrical, or it may be in the form of magnetic, or it may be in the form of optical energy. So in which form it will store the binary bits, whether it may be in electrical form, or it may be in magnetical form, or it may be in optical form. Okay. And while coming to the need of memory, the memories are designed to store the binary information. And in construction, what are the basic building blocks to design the memories? So in construction we are using registers. So what are the basic building blocks of memories? Registers are used. And see, in registers what are the building blocks? Flip-flops. So finally, in the memory, what are the storing elements? Flip-flops. Okay. In memory, one register consisting of one flip-flop means that is called cell. So once I would like to revise by drawing the diagram. See, if it is a memory, if these are the locations, that means registers. The locations consisting of group of flip-flops. All these are flip-flops. Okay, these are flip-flops. These are flip-flops. Okay. So here each and every flip-flop is called what? Cell. Each and every flip-flop is called cell. Okay. The group of cells is formed one location, simply one register. Okay. Each and every flip-flop is called cell, and one register is called one particular memory location. Okay. In this way, the memory is made with group of locations. Indirectly, it is made with group of registers. Is it clear? Internally, it consisting of flip-flops. What is the capacity of each flip-flop? 1 bit. So, what is the name of the flip-flop in the memory? Cell. Okay. And in which way it will store the energy or binary information? It stores the energy either in electric form, or in magnetic form, or in optical form. Is it clear? So now we are going to discuss, that is also the last class topic, what are the main classifications of memory. So here the memories are basically classified into two types. What are the two memories? Primary memory and secondary memory. What are the two basic types? Primary memory as well as secondary memory. The primary memory means it always have provide the connection between the CPU. It is directly accessed by the CPU. That memory is called primary memory. If the memory is not directly accessed by the CPU, then that memory is called, if it is not directly accessed by the CPU, then the memory is called secondary memory. So while coming to the secondary memory, the examples are hard disk drives. Means those memories are externally connected to the computer are called secondary memories. Those means if the memory is inside in the computer, the memory is located inside in the computer and it is directly accessed by the CPU, that memory is called prime memory or main memory. So what is the name of that memory? Primary memory or main memory. If the devices those are connected externally to our CPU is called secondary memories. What are the examples of secondary memories? hard disk drives, magnetic tape recorders, etc. Okay. Now see here, and based on the accessing, the memories are classified into two types. One is called random access memory and the other is called direct access memory. Next one is sequential access memory. Basically these are of two types, sequential and direct. So random is also there sometimes. Okay. So in sequence accessing memory, the locations of memory are accessed directly one by one. For example, if I would like to store the data in fourth location, must and should I would like to open the locations 1, 2, 3 also. Okay. After entering the data into 3 locations only, the data must be entered into the fourth location. But in direct access memory, if I would like to store my data into the fourth location without accessing 1, 2, 3, even though nothing is there in these 3 locations, my data is directly entering into the fourth location. But in sequential memory is not like that. If I would like to enter the data into the fourth location, first you must and should enter some data into the first 3 locations. Then only we are unable to access the fourth location. So this is called sequential access memory. In sequence only, the locations of the memory can be accessed either for the read operation or for the write operation. And while coming to the next one, direct access memory. So next one is called what? Direct access memory. So while coming to the direct, so irrespective of all other memory location, the required location can be directly accessed either for the read operation or for the write operation. And see, and according to their accessing, the memories are classified into random access memory and read only memory. So according to their access, the memories are classified into two types. What are the two types? Random access memory, read only memory. While coming to the random access memory, here we are able to enter the data and also retrieve the data. Both read and write operations must be done with the RAM. Okay, here we are able to enter the data and also retrieve the data. But in ROM indicates read only memory. The name itself indicates it is read only memory. Here there is a possibility of only reading the data. We are unable to enter the data. We means users are unable to modify the data already is there in memory, and we are unable to enter the new data. Just we only read the information from the memory. So these memories are called read only memories. The random access memories are also called read write memories. Why? Because here there is a possibility of enter the data into the memory as well as retrieve the contents from the memory. But in read only memory, we are able to read the information only. We are unable to modify the information, or we are unable to enter the contents into the memory. These are the memories according to their access, according to their read write operation. Okay. So next two memories are there. One is called static, other is called dynamic. Okay. Simply it is also called volatile and also called non-volatile. So in volatile memory, if the power is switched off, the entire contents must be lost. If the data must be lost, if the power is switched off, entered data is lost, then that memory is called volatile. So non-volatile means if while entering the data, even though the power supply is switched off, that data must be retained till the power is switched on, is called non-volatile. Is it clear? In volatile memory, if the power is switched off, the saving data must be erased. But in non-volatile memory, even though the power is switched off, the contents must be again there. So this is about what? Volatile and non-volatile memory. Here random access memory is the example of volatile memory, and read only memory is the example of non-volatile memory. Is it clear? So this is about what? Volatile and non-volatile memory. And while coming to the block diagram, so see, in block diagram already we watched this. It consisting of one buffer registers to enter the data and to receive the data, and also it consisting of address register to give the address of the locations, and also having two controls, one is called write, the other is called reads. Okay, so this is the block diagram of memory unit. How many number of blocks are there? 4 blocks are there. What is the first one? Memory unit. It contains locations in the form of registers. And next one is address register. So through which, means this is the register is used to store the address of the memory locations. Fourth address is 001, 0100, first address is 000, and here all the memory locations are addressed with binary numbers only. How can we address the memory location? With binary numbers only we can address the memory locations 0000, 0001, 0010, 0100. Okay, if we are able to give the address of memory location in a particular register, it is easy to access that particular location. So that here the address register is used to store the address of different memory locations. Okay, and while coming to the buffer register, it is used to enter the data into the memory or to receive the data from the memory. And then what is the use of this register? To provide the accuracy, and also it acts like a interfacing device, but it will not modify the data, simply it will send the data from one device to this memory. Okay, and see here, next important point is control lines. So one is called write, other is called read control line. So if we are applying clock pulse across the read bar signal, the operation inside going is what? Retrieve the contents from the memory. That means fetching. If write is enabled, now we are able to enter the data into the memory. Okay, if write operation is done by applying the high level clock pulse across the write control signal, and the read operation is done by applying the clock pulse across the read signal. So this is about what? Block diagram of memory. Okay, so these are the topics we are discussed in our last class. Okay, and now while coming to the today's topics, first one is what? Working of diode RAM. So see here, this is the block diagram of diode RAM. So the name itself indicates is the read only memory, and it is made with diodes. Okay, the name itself indicates what is the name of this device? Diode RAM, diode and ROM. So the device is read only memory. Read only memory means it is used to store the data permanently. It is used to store the data permanently. So to store the data, which elements are used here? Diodes are used. That's why it is called diode ROM. Okay, it is a read only memory. Here we are storing the data permanently. That means even though the power is switched off, the data must be saved permanently. And see here how the diodes are organized to the decoder. Okay, with help of decoders, and diodes are arranged in a fashion to form the diogram. So how the diodes are connected? See here, it is a 2 by 4 decoder. It is a 2 by 4 decoder. That means here we are applying 2 inputs and it having 4 outputs. How many number of inputs are there here? 2 inputs. And how many number of outputs are there here? 4 outputs. What is the first bit? 0 0, second bit 0 1, next bit 1 0, and last bit 1 1. How many number of outputs are there here? 4 outputs. How many number of inputs are there here? 2 inputs. Why? Because it is a 2 by 4 decoder. Is it clear? And see here, while coming to the diagram, see here, Here the first row consisting of, here the diodes are arranged in the form of rows and columns. The first row, in the first row 2 diodes are connected, and in the second row only one diode is connected, and in third column 3 diodes are connected, and in fourth 2, and in fifth 4. And see here how these diodes are connected, how the output will be produced according to this. So once see here, it is used for enter 1 byte. So how it will store 1 byte? Okay, for example, if the bit is D0, if bit is D0, so no diode is in activated condition. Okay, if bit is D1, that means only particular bit 1 is in active condition, remaining all other is in 0 condition. Next, if it is 2, 0 and 1 is connected to the VCC and remaining are not connected. Okay, and if it is D3 and it is D4, D5 likewise, so the wanted diodes only connected to the VCC and remaining 2 are connected to the ground. So in this way it is used to store the 8 bits. Now once check the slide. Here the A0 and A1 are decoded by the 2 by 4 decoder and used to select one of the 4 rows. So what is the function of these? Are used to select one of the 4 rows. Only one row will be selected with help of these two. If it is 0, 0, first row will be selected. If these lines are 0, 1, second row will be selected. Third 1, 0, fourth row will be selected. 1, 1, fifth row will be selected. If the decoder output is active low, it places the logic 0 on the selected row. If the output data lines goes to logic 0, if a diode connects the output data column to the selected row, okay, and data is available on the output data lines only when the output enable signal is 0. So when we are getting data, once see here, here one special signal is there na, output enable bar. So what it is? Output enable bar. So output enable bar is equal to 1 means what? Output enable is equal to 0. If output enable bar is equal to 0 means what? Output enable is 1. So output enable is under set condition when OE bar is equal to 0 only. Is it clear? Output enable is in set condition only when output enable bar is equal to 0. That means what? Here output is enabled or the output is produced across the diodes only when OE bar is equal to 0. Is it clear? The output is produced across the diodes only when OE bar is equal to 0. If OE bar is equal to 1, the output is not produced across the diodes even though the input is present. Even though the input is present. Is it clear? That is the necessity of output enable bar signal. If output enable bar signal is 0 only, the outputs are produced across the diodes, okay, after the applications of selection lines. But if OE bar is equal to 1, even though the inputs are present, the output is not produced across the diodes. Is it clear? So this is the main theme of OE bar signal. And see, and this is the block diagram or truth table of our RAM diode circuit. How many number of diodes are there? D0, D1, D2, D3, D4, D5, D6, D7. So these are indicate what? Number of diodes or outputs. If we are applying 0, 0 across the address lines, 1 means D0 bit is 1 and D2 bit is 1. All remaining are 0. Once see the diagram clearly. If 0, 0, so which diodes are under active condition? See here. This is 1, so it is in activated condition. Okay, and D3 is activated, D4 is activated, D6. Remember, D1, D3, D4, D6. D1, D3, D4, D6. D1, D3, D4, D6. D1, D3, D4, D6 are 0 and remaining are in 1. Okay. And see here. Next for 0 and 1, D1, D3, D6 and remaining are 0. So if the diodes are switched on like this, first we provide 1010. 1010 means decimal 10 and hexadecimal A, and 010 means 5. 1010 means hexadecimal A, and next 0101 means 5, means when we will apply the 01 we are getting the bits like this. And if we would like to apply 1 and 0, we are getting 0110, that means 4, and 0110, 6. And if we are applied 1 and 1 across the selection lines, 1101, that is D. D means what? 13. And next 0101 is there, and that indicate what's 5. So in this way, depends upon the input signal available at the selection lines A0 and A1, some diodes will be switched on and some diodes will be connected to the supply voltage. On means they will be connected to the supply voltage, and remaining diodes will be connected to the ground. So these are the different contents of the ROM. Okay. So next one is what? Random access memory. Is it clear? What is our next memory? Random access memory. So that already I told you, random access memory, also called read-write memory. Read-write memory. Here it is a possibility of entering the contents into the memory and also retrieve the retrieve the contents from the memory. And here the random access memory is the group of registers. Okay, random access memory is made with group of registers, and each register is identified by a unique binary address. Okay, in random access memory, also called read-write memory, means what? Here there is a possibility of enter the data into the register and retrieve the contents from the register. But here it is made with registers, but each register is identified by unique binary address. How it is, once see here. Is it clear? So now this is called memory. These are called locations or registers. Here each and every register or location is identified with a special binary number. First register is addressed with 000, and second is addressed with 0001. Third is addressed with 0010. Fourth is addressed with 0011. Fifth is addressed with 0100. And sixth is addressed with 0101. In this way, how many number of memory locations are there? If suppose the memory contain infinity also, they are addressed with binary sequence numbers. Binary numbers, not random sequence, 0, 1, 2, 3, 4, 5, 6, like that, until FFFF also, okay, but not other numbers. Or hexadecimal also sometimes, but not other decimal numbers, either hexadecimal numbers or binary numbers. Okay, so this is the form of unique binary address. And see here, with help of these addresses, the data can be read from the memory location or write into the memory location. So what is the need of this addressing the locations? Why? Because it having so many locations, like one village having so many homes. To reach particular home we need address now. Okay, like that memory means it having group of memory locations. To reach particular memory locations, addressing of location is very important. Okay, and this address helps us to read the data from one particular memory location or to enter the data into one that particular memory location. Is it clear? So this is the need of addressing. And see here in already in last class I told you random access memories are of two types. How many types are there in random access memory? Two types are there. Those are dynamic random access memory and static random access memory. So see here, while coming to the static, the contents in the memory is retained as long as the power is available. Retained means present. They may not be deleted or they may not be erased even though the power is switched off. So that is said in one word, retained, retention. So what is meant by retention? Even though the power supply is switched off, the data remains in the memory. That memory is called what? Static memory. And it is also referred as temporary memory, permanent memory. Okay, the contents in this memory is retained as long as the power is available. Okay, and while coming to the dynamic memory, the content is retained for a very short period of time. Very short period of time only the content is stored or retained. If the power is switched off or withdrawn, the data must be lost. Okay, until and unless if the power is in the circuit only, the data must be stored. Otherwise, the data must be erased. So this is the main difference between dynamic and static. In static, the data is retained again, but in dynamic, the data must be lost or the data must be for only few minutes. Okay, this is about static as well as dynamic RAM. And see here, while coming to the dynamic RAM, the dynamic RAM, it stores only data in the form of capacitor. So in dynamic RAM, how it will store the information? In the form of electric charge. So which element is used in the dynamic RAM to store the data? Capacitor is used. Which element is used to store the data? Capacitor is used to store the data in the dynamic RAM. When capacitor is charged to high voltage, DRAM cell stores one state. When capacitor is charged to high voltage, DRAM cell one state. If capacitor is charged to low voltage, DRAM cell stores 0 states. Means in the charging condition of capacitor is considered as one state and discharging condition is considered as low state. But finally, dynamic RAMs internally consisting of capacitors as memory elements. Okay, capacitors as memory elements. And the package density is very high. Why? Because it uses one MOSFET and only one capacitor. Is it clear? Okay, see. This is the diagram of DRAM. So what is the main element here we are using as a storing element? Capacitor. So this element is the key element in the dynamic RAM. It is used to store the energy in the form of electric charge. If the bit line is connected to the power supply, it is in on condition and capacitor starts charging to maximum supply voltage, that means it store 1 bit. If capacitor is disconnected from the word line, now the capacitor is starts going to discharging. So discharging of capacitor indicates the bit stored in the circuit is 0 and the charging of capacitor indicates bit stored in the capacitor is equal to 1, and the energy would be applied to the capacitor through the transistor. Energy would be applied to the capacitor through the transistor. Is it clear? And while coming to the operation, once check the slide. When WL is selected, okay, right is selected. If BL is 0, once see where WL you are getting word line, and also, so this is the word line WL and this is the bit line BL. So word line is indicated with WL, bit line is indicated with BL. Is it clear? Okay. See, when WL is selected, that means word line is selected. Okay, if the BL is 0, the MOSFET is in off state. Already I told this. If BL is 0, means only WL is in on condition, then BL 0. One is selected means other is 0. If WL is selected means if BL is 0, WL, after selecting the WL, if we make BL is 0, MOSFET is in off condition and capacitor is in discharge condition, the voltage across capacitor is equal to 0. And in selecting of WL, if BL is equal to 1, the MOSFET is in on state and capacitor is charged to 1 bit. And next, for the read operation, when WL is selected, the potential across the capacitor appears as the bit lines. And if voltage across the capacitor is high, the output is 1. If voltage across the capacitor is 0, the output is 0. Once see here, if this WL right line bit is selected, means for the right operation, this bit is selected and this bit is equal to 1, indicates the charging of the capacitor, that it will store bit 1. If bit line is equal to 0, the capacitor is in discharging condition, it stores the 0 bit. And next one, in read operation, if bit line is equal to 1 means the capacitor voltage is discharged through the bit line and it will give the bit 1 to us. If bit line is equal to 0, no output will be produced. Is it clear? This is the simple circuit diagram of dynamic RAM. And see here, this chart will give us the differences between the static and dynamic RAM. Why? Because it is a very, very important question. Already we discussed all points, but once check the slide. Okay, in static RAM, the data must be retained as long as the power is switched on. What is the main advantage of static RAM? The data must be retained, present, as long as the power is switched on. And see here, in dynamic RAM, the stored data gets lost, means the data must be erased. The stored data gets lost and refreshing is required every time we want to save, like in our computers. Okay, if we press save only, our Word document will be saved. Otherwise, if the power is gone, all the data also will be gone. Okay, is it clear now? In dynamic RAM is simple like our Word document in the computer. In Word document or in MS Office, whatever may be the document, every time we are pressing save. If we are pressing save only, the data must be saved, otherwise the data must be lost. If the power is switched off, or the device will be switched off. But in the static RAM, even though the power is switched off, the data retains. Okay, and see here, the stored data do not change with the time, but in dynamic RAM, stored data changed with the time. And static RAM consumes more power and dynamic RAM consumes less power. Is it clear? And the static RAM is expensive. Why? Because it is used for the purpose of permanent storing, and the dynamic RAM becomes very economical, low cost. Why? Because here it is temporary memory. And see, static RAM, these memories have less packing density, but dynamic RAMs having high packing density. And while coming to the static RAMs, memories are not easy to construct. Why? Because these are permanent memories now. So while designing these RAMs, proper caring is very, very important. Why? Because it is considered as permanent memory. If we save the data in this RAM, if the data is erased, then we are facing so much problem. Okay, so that while constructing the static RAM, much care and precautions are very, very important. And in dynamic RAM, even though we are caring in construction or not caring, also the data is erased if the power supply is switched off, so that they have a simple construction. And see here, no refreshing is required and easy operation. The static RAMs, no refreshing means every time saving is not required for static RAMs. But dynamic RAMs, refreshing is required with additional memory circuitry and complicates the operation. Is it clear? And for the static RAM, no maintenance is there. For the dynamic RAM, maintenance is required, like pen drives, hard drives, etc. Okay, for the static RAM is inside of the device, no maintenance is required. So which one is cast? Static one is cast. Which one requires much more power? Static much more power. Which one store the data permanently? Static. So whatever the memory will store the data permanently, that is expensive, and also it would like to pay much more cost and much more power also it requires. But dynamic RAM, data is temporarily stored, no need of maintenance, no need of much more power supply, and also less cost. Okay, simple in construction. So advantages or disadvantages are balanced. Static RAM is permanent, dynamic is temporary. Static RAM is expensive, dynamic is economical. Static RAM construction and high power consumption, dynamic less power. Okay, here advantages also there, disadvantages also there. Here advantages are moderate and also disadvantages are moderate. Is it clear? And see here now, what are the advantages and disadvantages of dynamic RAM over the static RAM? Already I explained it in the chart, but once have a look here. It consumes less power. It means what here? Dynamic RAM. So dynamic RAM consumes less power because the dynamic RAM requires power only at the time of writing data and replenishing it. It requires what? Less power. Why? Because it requires the power only at the time of writing the data and replenishing it. And it consumes less power because the data is stored in the form of charge. Here the data is stored in the form of what? Charge, so that it requires less power. And here the cost of this one is very, very less. And it requires less number of transistors. Okay. And high packing density is there, as the number of transistors required is lesser. Okay. And while coming to the disadvantages, the charge across the capacitor in the dynamic RAM is likely to decrease with the time. Why? Because capacitor property is what? Charging as well as discharging. After the capacitor is fully charged, automatically it starts to discharging the data. So cause of that property, it will affect the storing information. Sorry. See here, the memory cells should be refreshed at regular intervals to retain stored data properly. Okay, the memory cells should be refreshed at regular intervals to retain stored data properly, and therefore the system complexity is more. So that the system complexity is more. And see here, while coming to the next topic, the differences between the RAM and the ROM. Already I told you what is the full form of RAM? Random access memory. And what is the full form of ROM? Read only memory. So see here, while coming to the random access memory, it is also called read-write memory. There is a possibility of entering the data and also retrieving the data. In read-only memory, there is a possibility of receiving the contents or retrieve the contents from the memory. And see here, while coming to the properties, first property is what? Volatility. So volatility is there for RAM or ROM. Already we discussed now. Said. So volatility is there for ROM only. So here the RAM is volatile in nature, as automatically erased when computer shut down. Volatile means erasing. The RAM contents are erased, but ROM is permanent now, so it is non-volatile. Is it clear? While coming to the accessibility, RAM can be directly accessed by the processor. Okay, means user. but ROM cannot be accessed by the processor. It can be accessed by the executed processor, means manufacturer. And while coming to the storage, RAM is used for store the data temporarily. Why? Because if the power is erased or the system is shut down, the data also will be erased. But the RAM is used to store the data permanently. Why? Because it is a non-volatile memory. Even though the power is switched off or the device going to shut down, the data retains again. And see here, hardware structure, next one. The ROM is in form of a chip file. So ROM looking like a chip, but ROM is generally optical drivers made up of magnetic tapes. Okay, RAM is like a chip, it is inserted inside of the computer, but ROMs are drives, okay, externally connected magnetic tape recorders like that. Okay, and while coming to the cost, costlier than ROM, RAMs are costlier. Okay, and RAMs means read-only memories are cheaper. And see here, while coming to the size, chip size means this random access chip size is larger than read-only memory. Why? Because read-only memory means like pen drives or hard drives are very small in size. And while coming to the writing speed, writing data to a RAM chip is faster process. Okay, writing data to the processor is a fast. And here in read only memory, writing data to the ROM is very slow. Okay, writing speed is very high in which memory? Random access memory. In read only memory, it is somewhat slow. And in storage limit, the random access memory chip can store multiple gigabytes of data. Up to 16 gigabyte also it will store the data. But read-only memory will store only megabytes, 4 megabytes, like our pen drives or memory cards having the capacity of megabytes only. And nowadays we are available gigabytes also. But while coming to the examples, static RAM, dynamic RAMs are the examples of RAMs. And while coming to the examples of read-only memory, programmable read-only memory, PRAM, erasable programmable read-only memory, and EEPROM electrically erasable programmable read-only memory. What are the examples of the ROM? These are the examples. First one is PRAM, programmable read-only memory, and the next one is erasable programmable read-only memory, EEPROM, and the next one is EEPROM, electrically erasable programmable read-only memory. These are the examples of our RAMs. Okay, and see here, and while coming to the next topic, need for flash RAMs. So what is meant by flash RAMs and need for the flash RAMs? Here the flash cell is based on the single transistor. How can we design? It is designed based on the single transistor, and it is controlled by the trapped charge, just like an EEPROM. Means electrical voltages are used here to enter the data. And see here, in EEPROM, it is possible to read the data as well as write the data. In flash device, it is possible to read the contents of single cell, but it is only possible to write the entire block of cell. Okay, flash term, there is a possibility of entering the data into all cells, but we read the data only from single cell. Data entered into whole cells but received from only single cell. So prior to the writing, the previous contents of the blocks will be erased. For example, in location, if I would like to write 5, previous data is 6. By writing 5, this 6 will be erased. Override, the data must be overridden. Okay, and in a flash chips do not provide sufficient storage capacity. Okay, means if we enter the second data, first data will be erased. So here the flash cards are in the form of two types, flash cards as well as flash drivers. And while coming to the applications of flash RAM, so this makes more attractive in portable, means carrying devices, it is very attractive. And while coming to the typical devices where we are using these are, see here, handheld computers like laptop and cell phones, digital cameras, mp3 cutters, music players, we are working the flash memory. Is it clear? And carryable devices we are using, and flash memories are used to store the mesh data, and also used in mp3 players, and also in cell phones, digital cams, handy cams, everything is worked with this flash memory. Okay, so in today's class what we are discussed, what are the differences between static RAM and dynamic RAM, and construction of diode RAM, and the differences between read only memory and random access memory, etc. Okay, so now I would like to conclude the class. So here some questions are there. See here, a RAM is called scratch pad memory or read write memory. Is it clear? Okay, so next one. So while coming to the long answer questions, explain the operation with the RAM diode RAM is 5 marks question, and all remaining are 3 and 1 mark question. Okay, now I would like to conclude the class.